Welcome student to this video tutorial on principle of electrical and electronics engineering. In this video we are going to see unit 5. Unit 5 title is Introduction to Electronics. The first thing is semiconductor. What is a semiconductor? Semiconductor is a material which partially conduct. Semiconductor is a material which partially conduct. We are having two material, one is silicon and another one is germanium. These are the available semiconductor, but silicon is most used in all the components because of its availability and usability. Next type of semiconductor, you are having two types. One is P type and another one is N type. Next we will see what is P type semiconductor and then what is N type semiconductor. P type semiconductor is nothing but if you add a trivalent impurities to pure semiconductor. If you add trivalent impurity to pure semiconductor, then that is called as P type semiconductor. It consists of holes. Here majority carrier is holes. In P type, majority carrier is holes and minority carrier is electron. Some trivalent impurities are gallium and ignium. These are some of the trivalent impurities. Next we will see what is a N-type semiconductor. N-type semiconductor, here pentavalent impurities is added to pure semiconductor. Here pentavalent impurities is added to pure semiconductor to create N-type material. It consists of large number of free electrons. Here majority carrier is electron and minority carrier is holes. That is opposite terms of P-type material. Some of the pentavalent impurities are phosphorus, arsenic and antimony. These are the impurities which are added to pure semiconductor to create N-type material. Next topic we will see construction and working of PN diode. PN diode, this is a symbol of PN diode. It is having two terminals, anode and cathode. It is a two-terminal device. One is anode, another one is cathode. How PN diode is made? It is made by connecting P layer and N layer. It is having one junction. It is having one junction and two layers. First layer, second layer. It is a two-layer one junction device. It is a two-layer one junction device. It has two terminals, anode and cathode. Next, let us see the construction of PN diode. You are having a P layer and N layer. You are having a P layer and N layer which are interconnected. Here holes is majority carrier. Here electrons is majority carrier. Here holes is majority carrier. Here electrons is majority carrier. When you interconnect these two, what will happen is the electrons will try to move from P region to N region. Similarly, the holes will try to move from N region to P region. What happens is it creates a barrier across the junction. It creates a barrier. That barrier is called as depletion region. You will have this region when the device is in off state. When the device is in off state, you will have this depletion region. Conduction can occur only when this depletion region is broken. Normally, it will not allow current to flow from P region to N region. This depletion region can be broken down by applying forward voltage. For silicon, PN diode, the breakdown voltage is 0.7 volt. For germanium, the forward breakdown voltage is 0.3. This voltage refers to that less than 0.76 volt, nothing will happen to this depletion region. But if you apply voltage above 0.7 volt, this depletion region will deplete. It is completely depleted in case of silicon. If it is in this case of germanium, if the voltage is less than 0.2 volt, nothing will happen to depletion region. But if the voltage is greater than 0.3 volt, the depletion region will be depleted and the conduction will occur. Current will flow from anode to cathode. In construction, we are having three layers: P layer, N layer, and depletion region. It occurs because of carrier movement from P layer to N layer and N layer to P layer. Next, forward bias. Forward bias is a condition if the anode of the diode is connected to positive side of the battery. If anode is connected to positive side of the battery and if cathode is connected to negative side of the battery, this condition is called as forward bias. When anode is connected to positive and cathode is connected to negative, this is called as forward bias. In forward bias, it will act as a switch. Diode will act as a closed switch. In forward bias, diode will act as closed switch. Okay, now let us have a silicon diode. This is a silicon diode. You can have two types of diode. What is silicon diode? Another one is germanium diode. This is silicon diode. Now it is in forward bias condition because anode is connected to positive, cathode is connected to negative. Now what will happen? This positive charge, it will push holes into the diode. Here the negative charge will push electron into the diode. This is forward voltage. From 0.1 to 0.6 volt, the device will be in off state. But when you increase the voltage about 0.7, the device moves from off state to on state. It moves from off state to on state, and this voltage is called as knee voltage. This voltage is called as knee voltage. This off portion is called as blocking region. This off portion is called as blocking region. This on portion is called as conduction region. This on portion is called as conduction region. This is blocking region. In blocking region, device will be in off state. In conduction region, it will act as a closed switch. Here it will act as a open switch. At the instant when you remove the battery from the diode, again the device will go from on stage to off stage. When you remove the battery from diode, it will go from on stage to off stage. Again depletion region will be created across the junction of the diode. This is your forward characteristics. Next one is we are having is reverse characteristics. Reverse bias condition. This is a condition where diode is acting as an open switch. Diode is acting as an open switch. Here anode is connected to negative, cathode is connected to positive. Now the diode is said to be in reverse bias condition. Now the diode is said to be in reverse bias condition because of its connection. It normally in reverse bias condition is acting as a open switch or open circuit. It acts as an open circuit. In reverse bias condition, what will happen? Theoretically, there is no current flow, but because of thermally generated carrier, there is a minor current flow. But because of thermally generated carrier, there is minor current flow in this device. Now let me draw the reverse characteristics. This is voltage, this is current. This is reverse voltage, this is reverse current. Up to certain voltage, that is a very minor current flow. This is called as blocking region. Reverse blocking region. This is called as reverse blocking region. If you apply a breakdown voltage, what will happen is the device will move from off state to on state. You will have a steep rise in the current, but if you make the device to operate in this region, the device will get burned out because it is not supposed to conduct during reverse bias condition. You are applying a very high voltage which makes the device to go from off state to on state. This is called as reverse conduction region. This is called as reverse conduction region. This is called as reverse blocking region. Normally device will be in blocking state with a small current flow. This current is called as reverse saturation current, where a minority carrier electron in P region and holes in N region wander over the junction, giving rise to reverse saturation current. What is happening is minority carrier, that is electrons in P region and holes in N region, they move towards the opposite side. That is, electron will try to move towards from P to N layer and holes will move from N layer to P layer. Now this movement, it creates a current flow. That current is called as what? Reverse saturation current. This is called as reverse saturation current. But when you apply very high voltage across the device, But when you apply a very high reverse voltage, the junction will break down and a large current flow occurs through the device. But this current will damage your device. You are not supposed to operate diode in this region. This is this is the this is the reverse characteristics of PN diode. In forward region, in forward VA characteristics, you are having two region. One is forward blocking region and forward conduction region. This voltage is called as breakdown voltage or forward breakdown voltage. This is called as reverse blocking region. This is called as reverse conduction region. And if you operate the device in this region, it gets damaged. This is called as this point is called as reverse breakdown voltage. This is called as reverse breakdown voltage because after this point the device will move into conduction. The device will be off state. Before this voltage, device will be in off state. Here, before the forward breakdown voltage, device will be in off state. After this forward voltage, the device will be in on state. This is your VA characteristics of PN diode. In forward bias condition, it is used as a closed switch. In reverse bias condition, it is used as an open switch. This is the VA characteristics of PN diode. Next one is application. It is used in rectifier circuit, clippers, clamping circuit, wave shaping circuit, and digital logic circuits. These are the circuits in which PN diode is used. Normally, in all the circuits, you will have PN diode as a switch. Thank you for watching this video. In the next video, we will see Zener diode and bipolar junction transistor. Thank you.